Welcome, everyone. Welcome to this day 2 of Copernicus Marine Service workshop dedicated to the Iberia-Biscay and Ireland region. My name is Andreia Carvalho. I'm a training officer at Mercator Ocean International. And today we're going to have a practical session. Co-hosting this session with me is going to be Ergane Fouchet from Noveltis. Hello, Ergane.
Hi, Andrea. Hi, everyone. Thank you all for being here. So I'm Ergane Fouchet. I'm an oceanographic engineer at Noveltis. And so I'll be hosting with Andrea this practical session. I hope you will enjoy the exercises we have prepared for you. Here are the guidelines and the material that we have developed. On the link here, the link will also be sent in the chat. You will reach the Padlet. On the Padlet, you will find all the resources that you need for the workshop. So you will find the replay from yesterday's session. Yesterday's session was about the presentation of the products and some use cases. You will also find all the e-learning material, all the practical material, everything you need to do the exercises, and also the participant manual. So yeah, have a look at the Padlet. We are having this meeting on Zoom. So you have the chat in which we can have small talk, but for the question, we ask you to use Slido. The link will be sent in the chat. On Slido, you can ask all your questions. You can also upvote the questions you are most interested in. Usually, we don't have time to answer all the questions, so you can upvote the questions. And also after the event, all the questions will be answered and you will receive all the answers to your questions. So here is the program of today's session. First, we will have 1 hour of Jupyter Notebook tutorials from Alexandre Homerin. Then we will have the MyOcean viewer tutorial. And finally, we will have the QGIS tutorial. So if you're interested in only one of this session, don't hesitate to only attend the session that you want. That's it. So yes. We can begin with our first speaker.
Yes, Alexandre Homerin, also from Noveltis, and he's gonna show us a Jupyter Notebook tutorial. Hi, Alexandre.
Hi, thank you very much. So yes, I'm Alexandre Homerin from Noveltis, and yes, today I'll be introducing you to the Python and Jupyter Notebook tutorials. So the first part, I will show you how to use a beginner notebook. And afterwards, I will give you a brief presentation of the results of the intermediate notebook. So I'll start sharing my screen and start my presentation. So welcome to this training on the Iberia-Biscay Irish region. So in this first notebook, I will show you all the ways to retrieve data and all the basic manipulation with Python on the Copernicus Marine Service products. So we've chosen here to look at sea surface temperature data. So we'll use a number of products. So one product will be based on model calculation. Another product will be based on satellite observation, and the final product will be based on in situ observation. So here are the 3 names of the product. So the Atlantic, Iberian, Biscay, Irish Ocean Physics Analysis and Forecasts, European Northwest Shelf, Iberia, Biscay, Irish Seas, High Horizon, L4 Sea Surface Temperature Analysis, and in situ near Earth observations. Okay. So maybe I should start by showing you how to download the learning material. So from the Padlet, you should have access to this Jupyter Hub environment, and the notebook will be here in the shared notebook folder. But you will have to copy this folder in your own user space. Otherwise, you won't be able to well, to do any modifications and to do your own manipulations on the notebooks. So I suggest writing a command similar to this one. So using the command copy, and this little command will enable you to copy the whole directory from share notebooks to your own. Here it's a directory that I've made myself. So I think someone will be able to copy this command in the chat to enable you to do this. So back to the material. So if you want, so back to the products, if you want to know more about the products, you can always see the dedicated pages. Here's an example with the model products. You'll have a brief description of how the product is made, how it's calculated, and its main characteristics such as spatial resolution, temporal coverage, and the variables that are available in the product. And you have also access to the user manual, the quality information documents, which are very useful, and you have the indication on how to access the data. There are several ways that I will introduce you now. So the first thing you can do to retrieve the data, to download it, is to download it from the catalog. So it's basically just going from this page, going to the products and clicking the download icon. And here you can choose your area of interest, etc. But I will not spend too much time on this because you'll have a presentation on this interface right after me. Another way is to use the multi-client protocol. So before using this, you just have to install the multi-client module in your Jupyter Hub environment using this cell. So this will install on your environment the multi-client application, and then running this command, so using multi-client, you will be able to retrieve the product that you have chosen. So to know what the multi-client link of your product is, you have to go back to this page that I've shown you, go to data access, and here you'll have the different links for the multi-client protocol. So here's an example. You copy the link here, and you should paste it here. Oopla. And then specify the name of the products that you're using, their identification, and you'll find all of this in this page, all the metadata you need. And then with date min, date max, you can specify the temporal coverage that you want to download, etc., the variable that you need, the directory you want it to be downloaded in, the name of the products, and of course, your credentials, your Copernicus Marine Service credentials, so the same that you've used to connect on this session. So those two cells download, here it downloads the model data, here it downloads the satellite data. Okay, so next method. There is also an FTP server that enables you to download the netCDF files. So here, the process is very similar. You have to enter your credentials here, so username and password, connect to the FTP, and now you just have to to use the product identification that you want. So same here, you'll just have to use the links and identifiers that are provided in this page. and it will retrieve you the netcdf files, and you will be able to choose which one of them you want to download. Finally, you can use the OpenDAP method. So in order to use, sorry, I'm just, okay. So in order to use this protocol, you first have to run this Python file here, which is saved here in the beginner directory. And just like before, it will make you enter your credentials, username and password, to be able to use the OpenDAP protocol. So same thing here. On the data access page of the product, you have the OpenDAP link that you can copy and paste. And in a few sections, you will actually see the product be downloaded. So we'll come back later to the OpenDAP protocol. Okay, so in this section, we will do a first exploration of the products with Python. So here are the Python models that we are going to use. We're going to use NumPy, which is very convenient for manipulating data arrays. If you are already familiar with Python, you're probably already familiar with NumPy. The netcdf files will be opened with the xarray library, so which is very commonly used to open netcdf datasets. And with Matplotlib and Cartopy, we are going to draw the maps, the graphs, etc. So here we import all those libraries, and we will be good to go. Okay. So of course, for this training, all the data has already been downloaded in this folder. So with these cells, we are just going to load all the data sets that we're going to use in this training. Okay, it's done. And here, here's the comeback of the OpenDAP protocol. So here's another example of how to open data. So with OpenDAP, you actually directly open the dataset from the link. So as you remember, this is a link that you copy from here. Just make sure it's the right variable that you are copying, but this is a method. And just with this link, you can already open the whole dataset with xarray. Okay, so let's see what we have loaded as products. So here is the model data that we have loaded here from the downloaded data. So here is our xarray dataset. So there are many things to see here. Here are the coordinates variable of the data. So we have time coordinates, latitude, longitude, and many levels of depth. Here you have a brief summary of those. We have 12 time dates, 24 depth levels, and 181 latitude points and 865 longitude points. If we look at time, we can see that it goes from January of 2022, so 16th, to December of 2022. So we have 1 year of data with monthly values, 12 values, 12 months, it makes sense. And here are the data variables that are available here. So here we have the seawater potential temperature. The units is shown here, it's in degrees Celsius. And here is the water salinity. Same thing here is expressed as particle salinity units. So in this unit, you could say, like, you could translate it to grams of salt per kilogram of water. So this is the data that we have downloaded either from the catalog or the FTP or the multi-client methods. And here is the data that we've downloaded with the OpenTab protocol. And we see that it is a little bigger. So we have we have more time values, we have more depth levels, etc. This is because, and we have more variables. This is because, as we have only provided the link to the product in the OpenTab with the OpenTab downloading, we actually have downloaded the whole product, whereas with the multi-client and the other application, we are able to filter only the variables that we wanted and only the time coverage that we wanted. So here we can see that it goes from 2020 to 2023. And here we have many variables that we are not necessarily going to use. So this is something to know when you use OpenTab. You may want to filter your dataset afterwards. Okay, so now we have seen that we have the potential temperature here. So to select a variable in a dataset, you just have to use brackets like this and write the name of the variable that you want to study as a character string. So we can see here that we have the same coordinates, only we are only observing the temperature variable. So here's another variation of this using the salinity variable. So if you add data after the line, you'll only save the values, the salinity values of the dataset. So it takes some time to load as an NumPy array. So we might have to wait a few seconds for this to execute. Okay, so it's finished downloading. We can see that we have only raw values here. Those are the salinity values. Which are displayed, which are not easy to read, of course, because it's a big table that is being displayed here. So to have a better idea of the shape of our data, you can use the point shape method to retrieve the shape of the data. So here we see it's of shape 12, 24, 1081, 865. And if we remember, this corresponds to the coordinate variables of the data. So here are the latitude and longitudes. The 24 refer to the 24 depth levels that we had here. And 12 here, we have 12 time values. And the first shape of here is also 12. So it makes perfect sense. Okay, let's do some more manipulations. In this section, I will show you how to subset the datasets in regards to the coordinates. So here we look at the temporal coverage of the data. So you can select the time coordinate just like you select the other variables. So here we can see all the dates in the data. And if you know a date that you want to select, you can use the cell method and write here the date that you want to select. Here, for example, the 16th of January. So here we can see that we have only one time value left. And so here, logically, we have 12 times as less values as before, with only one date in the time coordinates. So it makes sense. So let's say now that you know you want to select a date, but you're not sure whether this exact date is in the dataset. So here, for example, I want to select the 5th of July 2022. But here, for example, the 5th of July is not in the data. We have only in July the 16th. So you can use the nearest method in the cell function, and it will select you as the name indicates, the nearest date in the data. So if we do this, so we've tried to select the 5th of July. And if I look at my time coordinate that I have retrieved, I only have the 16th of July, which was the closest date. Next, you can also select a time coordinate according to its position, its index. So just add brackets and the index number that you want to select. So here I want to select the 7th value, because of course the index starts at 0, not at 1. And here, as I said, I've selected the 7th value, and indeed I'm on the 7th month of the data, July. And finally, this method is probably a method that you will use many times, which is selecting a range of data. So just like before, you'll use a cell function, but here you'll use the slice method to provide 2 dates, and it will select all the dates between these 2. For example, I'm selecting from May to September, beginning of May to end of September. And if I look at the time values that I have retrieved, I have 16th of May to the 16th of September. So now I'm going to show you how to plot a map of data. So as it is said here, we're going to plot the sea surface temperature on July 2022. So first thing you need to do is to select all the data you need. Here, so I'm selecting temperature, potential temperature. I'm selecting depth equal to 0 meters because I want to look at the surface temperature. And I said I wanted to see it in July 2022, so I'm selecting my date, 16th of July. And all those lines are for drawing the map. So setting up the window, setting here the extent in longitude and latitudes of the map, the projection method. Here is the part where you draw, where you plot the data in the map. You can see that here, your variable that you have created here with all the selections is back here. And here are for the titles, legends, and the colors of the map. And this last line here is for saving the figure, saving the map in your own folder. So maps also take some time to draw. Let's just wait a few seconds. Okay, so apparently this cell has decided not to work, so we'll have to move on to the next section. Okay, so in the next session, I will show you how to manipulate the dataset values. So here we'll move on from the model product to the satellite product. Perhaps we can take a look at the product to see what it looks like. Okay, so apparently nothing is working anymore. I don't really know what's going on now. It should be very fast. Oh, okay, so the map has finally finished drawing. So, back to the map. So as you can see, we have plotted the sea surface temperature in July 2022. You have your color map here in degrees Celsius. So now the map is drawn, we are reassured, we can move on to the manipulating section. So here's our data set, and we can see that in our sea surface temperature, we have a value that is called analyze SST. So analyze sea surface temperature. So this is a variable in the satellite observation product that we are going to look at. So here we go. Just as I've shown you before, this is just selecting the variable. Here it's easy because there is only one. And so here this temperature is in Kelvin, and we want to convert it to degrees Celsius. And if we do that, we can just subtract 273.16 to the variable, and it will apply the subtraction to all the values in the dataset. And of course, you can save this result in a new variable and even save it into the dataset to have well, a new variable in the dataset. I can maybe try to do it live, but hopefully I won't mess anything. But I won't mess up. And you should already be able to write a new variable with this method. Here, new variable with in degrees Celsius. Of course, there are ways to do it cleaner than I did, because here you can see that I don't have any metadata like in the SST variable. Here I can click on this. There are methods to properly create a new variable with the specification of the metadata, so specifying degrees Celsius as units, etc. But if you want to work fast, this is a quick way to save a new variable in your dataset. Okay, so now I'm going to show you how to plot time series of data. So we are still using our satellite products that now you are starting to know it. So now we can see that I have my new variable saved in the dataset. So we'll still be looking at selected at the analyze SST variable. And we're going to plot the time series from July 2022, the first to the end of July 2022. And of course, to plot the time series, we're going to select our data spatially. And so we're going to extract this coordinate point and see what the time series looks like. So here are our values. Here they are converted to degrees Celsius. So here are the 31 values on the coordinate point that we have selected. And with this cell, we're going to just draw the graph of the time series. Okay, so apparently now graph drawing goes fast, so it's perfect for us. So here in this minimap is the point that we have selected, that we have extracted the data from. And here is the time series. You can see it goes from the 1st of July to almost the 1st of August, so the 31st of July. And we can see here, for example, in this particular area, apparently the temperature has increased over July 2022. And as an exercise that you can do later if you want, you can try to do the same thing at another location. So basically, it should just be about changing the coordinates here. So I'll let you do it, and you can also do it on another month. Okay, so now let's plot vertical profiles. So in this section, we are going to study this time an in-situ product and plot vertical profiles, because those products cover many depth levels. So here is a little pre-processing of the data. And so here we can see that for one date, we have indeed almost 100 depth levels. So this is what will enable us to draw our vertical profile of sea temperature in degrees Celsius this time. Okay, so in this cell, we have drawn the three graphs. We actually have taken three different in situ measurements. So here are the vertical profiles, and each curve is the vertical profile at one specific date. So we have the 18th of July 2022, the 18th of June, sorry, 11th of July, and 24th of July 2022. And so as an exercise, you can always copy the previous cell and plot other indexes. Okay, in the next session, we will plot vertical slices. So we will combine depth level to data extraction at specific areas. So here we're going back to the model product, and we actually are going to select a slice on the map. So here it will go from this latitude to this latitude with a constant longitude. So we're going to plot a vertical slice here. And let's see what we have. So we're plotting this slice with all the depth levels available in this area. So here is the seawater temperature on the 16th of July. And we can see that it makes sense that near the coast, the depth is smaller than in the open ocean. And it also makes sense that the temperature is colder near the bottom than near the top, near the surface. Sorry. And so, as an exercise, you can change here the longitude and latitude values to plot another slice at another location. You can do it vertically or horizontally. It's as you like. Okay, as a final section in this presentation, we'll see how to create an animation of maps. So basically what we're going to do is in this loop, we're going to generate many graphs. And finally, we will animate them. So we will concatenate them together and make a GIF image. So this should take some time. So we're doing the same thing, a vertical slice. This is the same calculation that we have made before, only we're doing this on many dates here because we are looping it over the time variable. As we can see here, we are plotting the vertical slice for January, February, March, etc. until December. So the cell has finished executing, and hopefully we'll be able to see the animation. And here we go. Okay, so the animation doesn't loop, but I'm just going to re-execute the cell once more so we can see the animation again because it's really a really pretty animation. And we can really see the warming of the surface during the summer and the mixing of the water between summer and winter. So it was pretty relevant to plot this animation. And we are approaching the end of this beginner notebook presentation. So I hope you have enjoyed it. And of course, don't hesitate to come back to it by yourselves and do the little exercises that are specified here along the presentation. So I hope you enjoyed the presentation. And of course, if you have any questions, don't hesitate to contact us about the notebook.
Thank you very much, Alex, for this first presentation. We don't have many questions. We only have 2 for now.
Okay.
Maybe we can answer them now before
Sure.
moving on.
Yes, we can. I will share my screen so you can see them. So they are more like comments or like, yeah.
We have one
build-ups.
question.
So the first one, there was someone saying that the salinity variable is too large to open in OpenDAP. I don't know if you found the same problem, Alex.
I didn't actually. It worked fine for me, so I don't really know where this problem may come from. I'm sorry about this.
Okay. The second one, there was also a warning. I was installing the Mutu client and I got this warning, the script Mutu client is installed in home, which is not on path. Maybe consider adding this directory to path. This is my first time.
Okay.
Is there
This sounds weird. And if it installed, have you tried to execute afterwards the downloading process with the multi-client app? Does it detect it, or does it still not work?
Maybe we can, leave that.
Yeah,
in
maybe
the
we can
comments.
investigate it afterwards and see if this happens. But yeah.
Okay. Thank you. So there's another question. In the vertical plot, set the indexes of the measures to consider. How did you select these numbers?
Well, these numbers correspond to dates, actually. So basically, I just knew where the dates I wanted to select were located. So I've selected the numbers with this aim. So
Yeah, I see. Okay. Oh yeah, this one is already done. Can the animation be programmed to automatically restart the final animation? Right?
we'll have to see this in the documentation of the animation functions. I've never used this animation with as a restarting animation. So
if I may, I think you can program it to repeat several times. Like you can say,
okay.
I wanted to repeat 5 times. Yeah.
Good. Oh, that's it. Can we access the presentation notebook? I think they mean the
that may be a question for you or
document.
Ergane,
Yes.
maybe. Yeah.
Yes, so the notebooks will be, they are already available. You can access them through the link that we posted on the chat. You will also find that link in the Padlet in the participant manual. And you will also be able to find the replays of this session, so you can go through Alex's presentation. So yeah, everything is in the participant manual, but we will post it again on the chat, the link to the Padlet and the link to the Jupyter Hub as well. With the Motu client, you can download the complete database, for example, all the time data series, or there is a restriction on the size.
I'm not sure about this. There probably is, but I've never encountered such a problem. Anytime I have downloaded data through Motu client, so if there is one, I'm not aware of it.
Next one. I would like to know how to add the path to the directory.
The path to what exactly? I'm not sure I understand the question.
Okay, yes, it's not very specific, it's true. if you want to specify your question, dear participant, you can do it on Slido. We can move on to the next one. Can you recommend online tutorials or examples for using R to work with Copernicus marine data? I think, well, we have a few tutorials, but they're not so recent, right? I think they're from a few years ago, but I can say that soon we will be developing R tutorials as well.
Andreia?
Oh, yes.
Cedric speaking. Yes.
Hi.
Good morning, everybody.
Good morning.
Yes, just the cam. There are several articles about R in the App Center. So in the search area of the App Center, you have to just to specify R, and you will find several articles. I will share the link in the chat.
Great, thank you. Great. Okay, this one maybe. Can we have the record? Okay, this is so far. Yes, sure. So the recordings of this session, today's and yesterday's session, will be in the Padlets, and later on also on our YouTube channel, Copernicus Marine Service YouTube channel. So we'll be able to see all of this again and pause whenever you want. It's true that this notebook tutorials can be a bit overwhelming if you're a beginner, but you will be able to do it in the future. Okay. Thank you very much, Alex, for answering all the questions. And
thank you very much.
And now you have a short demonstration for a advanced notebook.
Yes.
Right. Great. So now for
okay.
more experienced people. Okay. The floor is
So
yours.
I'm just share my screen again. So you should be able to see it fine. So, okay. So now that we have seen the beginner presentation notebook, I'm going to briefly introduce you to the intermediate level notebook. So on the Padlet, there should be a video available of the complete tutorial. So here I'm just going to briefly show you the results that you will be able to compute in this notebook. So here we're going to manipulate wave data in the Iberian Biscay Island region. Of course, wave data is very important in many sectors, from navigation to energy, because industrial, for example, need to conceive oil rigs or wind farms are able to resist extreme weather conditions. It's also important for marine institutions, touristic activities, etc. So this is why we've chosen to look at this physical phenomenon. So here's a brief overview of the Python modules that will be required in this notebook. So as you can see, it is pretty similar to what we had in the beginner notebook, with pandas, which is powerful to manage tables. So Matplotlib, Cartopy, Datetime, all of this is well, almost very similar to the beginner notebook. We're going to do the imports. Here is the main product that we are going to use, which is the Atlantic Iberian Biscay Irish ocean wave reanalysis. So here is a brief summary of the characteristics. So it's approximately 5 kilometer resolution. It gives the hourly data, and it goes from 1993 to 2021. So same thing as in the beginner notebook. If you want to know more about the products, you can go to the dedicated page where you have all the information, the user manual, quality information document, and the ways to access the data. Here, in this notebook, you will have to download the product with OpenDAP because it's a very big product, and with OpenDAP, you shouldn't have any trouble downloading it in a fast way. So here is the product with all the variables. So we will be looking at here this variable, which is significant wave height expressed in meters. And we also take a few looks at the wave directions of the three separate components. The first primary swell here, the secondary swell direction, and the wind wave direction. So then we will plot a basic map of the significant wave height at a very specific date. Here, for example, is the 30th of October, 2019 at 6 a.m. So here is the map. Then we'll take a closer look at those islands, because as you can see, the waves are smaller south of the island than north of the islands. So this is where we look at the directions of the three wave components, primary swell, secondary swell, and wind waves. So with these, we zoom on the Gran Canaria island here. So as you've seen in the beginner notebook, we do a subsetting of the datasets, selecting our date, selecting our range of latitude and longitude to zoom in on the island. Here we are computing the vector field to show the wave directions. And finally, we are doing this big plot of the direction of the three components: primary swell, secondary swell, and wind wave. And so as you can see, for secondary swell and wind wave, we indeed have a north to south component in the direction, which could explain why the significant wave height is smaller south of the islands than north of the islands, because those islands actually block the propagation of some of the waves. In the next section, we'll take a look at seasonality in the wave data. So here, what we will do is take 20 years of data from 2000 to 2019, average it on a specific area. So here we will look at the average wave height near the coast of Ireland. And we will separate the data month by month and plot box plots of the data. So here is just a time series of the 20 years of wave heights over this area. So as we can see, there is a regular pattern here. So this suggests already a seasonal pattern in the data. And here are the box plots month by month. So to briefly remind you what the box plots show. So for example, here, January, this whisker here extends to the minimum value of wave height in the distribution. So only for the month of January over the 20 years. Here is the 25th percentile. Here is the median of the distribution. Here is the 75th percentile. So this whisker extends to the 99th percentile, and so the remaining points are the last percentile of value. So these are really the highest waves. We could say the extreme values. So I've chosen myself to have this kind of extension. So this is a whisker attribute, which goes from 0, minimum, to 99th percentile. And as we can see here, the waves are indeed smaller during the summer, so near June, July, August, than in the winter, where the highest waves are located. In the next section, we'll take a look at in situ wave data. So I may have forgotten to, in the previous presentation, to show you where to retrieve in situ data. So you have to go to the CMEMS in situ Thematic Assembly Center. And this dashboard here will enable you to look at many in situ measurements. And here I've selected my data, filtering the wanted physical measurements by wave. And here you can select the in situ measurements that you want. You can here quickly check their temporal coverage, for example. I have chosen the in situ sources that had at least 20 years of data, so perhaps not this one. So going back to the notebook. So in the data, you'll see that I have downloaded, I think 9, it is 9, yes, 9 in situ datasets. So in this first example, I'm taking only one dataset to show you an example. So once again, I open it with X-array, look at the variables, look at the many variables that they are. We can see that there we have the significant wave height variable here. And we also have this variable, which has the QC added to it, QC standing for quality check or quality control. So as I will show you later, this is actually a quality flag that has a value depending on the quality of the measurements of significant wave height. Oops, sorry, I wasn't supposed to execute the cell. But it was just a time series of the significant wave height measurements. So as I said before, this is the quality check flag. And so each value stands for quality evaluation in data. So 1 stands for good data. We have 4 that stands for bad data. And here I plot the time series of the in situ wave height along with the quality flag. And we can see that most of the data is labeled as good data, but only a few here and there, we have values that are flagged as bad data. And so in this cell, I just perform a cleaning of the data, removing all those bad values from the dataset. Okay, so now we have our clean dataset. Here I'm doing a resampling because, as you can see, there are holes here in the data, which means that over 20 years of data, we should have 175,320 values. But in this dataset, we have less because we are missing data points. So I'm just here doing a resampling at with an hourly time step, just to make sure we have the right number of values. Basically, I'm just creating empty data points in the holes here. I'm doing this because I want to compare the in situ data to the model data, which is not missing any data points. I want the 2 data sets to have the same size over 20 years. So I'm extracting data from the model at the same point of my in situ source. So here's my time series of model data at the same location. And here I'm plotting a quantile plot of the 2 datasets. So vertically, I've plotted the in situ distribution. The values are sorted from minimum to maximum. And here are the model values. What's important to note here is that in waves that are between 0 and 4 meters high, value in situ and model values are quite similar. So this curve is close to the identity line. So y equals to x. But as we go to the highest waves, we can see that the model values are generally smaller than the in situ values, which suggests that at this particular location, the model may underestimate the most extreme waves that can happen in this area. So this is a quick in situ versus model comparison. And finally, in the last section, I will show you how to compute a few indicators to monitor extreme wave events. So here I'm taking a look at all the in situ datasets that I have downloaded. So as I said before, I'm doing the same pre-processing that I have shown you before. So cleaning the data to make sure there are no values flagged as bad data. So here are the datasets that I have chosen. So here are the location with their names. So if you have time, you can go to the Copernicus Marine Service Thematic Assembly Center to see if you can find them. You should be able to. Here are the 9 time series of the datasets. So we can see that depending on which dataset we are looking at, we have different temporal coverage, different quality of data, because especially in this one, we can see that there are many holes, for example, in 20 years. And there is this one, for example, there is no data after 2020. So yeah, when we're dealing with in situ measurements, we have to keep in mind that sometimes the data is not as clean as in model data, which is perfectly normal. And I will use all these datasets to compute extreme wave anomalies. So to compute extreme wave, I'm calculating the 99th percentile of the distribution. So here I'm calculating the 99th percentile over the 20 years, 15 years, sorry, this time of data. So from 2005 to 2019. And I'm calculating the anomalies that happened in 2020 and 2021. So I'm calculating the 99th percentile in 2020, 99th percentile in 2021, and I'll basically will be comparing them to the 99th percentile of the 15 years reference period to compute the anomaly of those 2 years. And here is a summary plot of the results. So here are the 99th percentiles over the period 2005-2019. So we can see that the waves tend to be, extreme waves tend to be higher in the north than in the south. And if I look at the anomalies in 2020, I can see that the extreme wave in 2020 were generally higher than usual, except on this particular dataset. And in 2021, we can see that it is the contrary. The extreme waves were generally smaller than in the reference period. And I'm just noting that this dataset corresponds to the dataset that I have mentioned before, which didn't have any data in 2021. So in 2021, this ET2 dataset is not to be considered, which is why here the white color probably stands for 0 because it didn't retrieve any value from 2021. And another indicator that we will compute is studying the frequency of strong wave episodes. So here I've done this in a simple way. So I'm just going to count the number of strong wave days every year. So I've chosen to define a strong wave day as a day where the mean value of significant wave height is above 4 meters. So it allows me to just compute that by doing a daily resampling of the data and counting for every year the number of days where the significant wave height value is above 4. So this is what I'm doing here for the 15 years reference period. Once again, I'm doing the same thing for 2020, 2021. So here I'm doing this little if loop to not take into account this dataset that doesn't have data in 2021. I'm doing this so this cell doesn't yield any errors. I'm computing the same table as before and plotting the same plot as before, only here we are looking at a number of strong wave days in 2020, 2021. So here we have, well, new results. So apparently in the north, there were apparently more strong wave days in the reference period than in the south. So it is quite consistent with the observation that we had made before. In 2020, we can see that there were generally more strong wave days than in the reference period. And this is true for almost all of the in situ sources locations. And in 2021, it's more mixed. We can see that near Ireland, there were more strong wave days, but near the Iberia Peninsula, apart from this location, we can see that there were slightly less strong wave days than the reference period. And so I'm getting to the end of the notebook. So you will see that there are some exercises that you can do. So you can do basic things like plotting the maps of significant wave height at other dates, zooming in on another island. Next, you can study the seasonality of the data on another location, for example. You can add new in situ sources to this analysis, going on this portal and choosing other datasets. And finally, if you feel like you can do it, you can try to compute other extreme wave indicators. So I'm proposing this one to you. You can try to count how many times per year the significant wave heights is more than 5 meters for more than 12 consecutive hours. It looks easy, but you will see that it's a little bit trickier than you would expect. So I am now at the end of my presentation. Well, thank you for your attention, and I hope you enjoyed it, and I hope to see you in a few weeks for the debriefing session. So thank you, everyone.
Thank you, Alexandre, for your second presentation. Again, very interesting. We have a few questions again. Yes, great.
Perfect. Thank you. So, oops. Oh yeah, let's get on.
Okay, so the question is, what Python version are you using? I'm not sure if you access this information on the Jupyter Hub.
I'm not sure either. I'm in the CMEMS environment, so I don't know which Python version it's using. I don't know if I can do a quick check in the terminal, but I have, if I run Python version in the terminal, I have 3.7.3. So it should be the same as yours.
Okay, thank you. I think that's a good answer.
Yeah,
Second
that's what I
question.
have, 3.7.
Is there a way to get the buoy parameter from your data in order to reconstruct the directional wave spectrum?
I'm not sure about this. So if maybe you can take a look at all the variables available with the buoys, because there is I think a wave direction parameter. I'm not sure if that's what you're looking for.
Okay. Maybe
but you should be able to reconstruct wave direction from the in situ datasets.
Okay. Do you have information on how to calculate the SWH in buoyed data?
I don't really exactly know how it's calculated. You could take a look at the user manual of the products to get a better explanation that I would be able to give you, I think.
Thank you. And the last question, yes. In the previous exercise, the person didn't had any error in retrieving the temperature, but salinity was too big. Well, that's kind of the same question we had before. Maybe we'll have a look and we'll answer later.
Yes, I've seen your error message that you've sent in the chat. Yeah, we'll take a look and get back to you with an answer, hopefully.
Thank you. I think
Thank you.
this is all for the questions. So now we will have a brief demonstration of MyOcean Viewer by Anaïs Perrin. She is a user support officer at Mercator International, and she will. Yes, hello, Anaïs. So the floor is yours whenever you want.
So, welcome everyone. I'm Anaïs from the user support team of Copernicus Marine. I will introduce you the main feature of our MyOcean Viewer Pro. To access it, you just have to click on Ocean Visualization here. So you have our 3 different ocean viewer, the MyOcean Learn, dedicated to beginners, the MyOcean Lights for intermediates, and the MyOcean Pro for experts like you. So 2 layers will be open by default on your interface. By passing your mouse over the name of the variable, you have access to the name of the open product, as well as the dataset and the variable. These two layers come from a global forecast product, one for physical data, here temperature, and the other for biological data, here chlorophyll. In our case, it will be interesting we will be interesting for these 2 variables, but it will also interesting to add the current speed for the EB region. To search for a project through our catalog, you just have to click on Add Layer, and you arrive on the Copernicus Marine Data Store. Near 300 projects are present. We therefore have all our projects classified according different categories, the most popular, indicators and trends, new in Copernicus Marine, and so on. The short description of the projects informs us about the name of the project, the data assimilation mode used, whether it is a model or an observation like this, but also about the temporal coverage here and the variables present in it. So filters column on your left allows you to refine your search, either by entering keywords or by informing the time period, or by clicking directly on the parameters corresponding to your search. So I can write here velocity, okay, or even mark it as a variable here. I will add EB region for the area. I will choose hourly for temporal resolution, and I will stay on the numerical model. So we are with our 4 products corresponding to our search. If you look into a little closer on the name of this project, you see that the first is the forecast project containing physicals variable like mixed layer thickness, salinity, sea surface height, temperature, and velocity. The another is a forecast project, but for wave relative variable. The last 2 are multi-year project and not forecast. So I will choose the first. So we arrived on the description page of the project with its presentation. The reference is used and a part on the parameters taken into account for this one, like variables, temporal extent, temporal resolution, and so on. On the left, you will see other tabs like a notification that tracks all incidents, improvement, and maintenances in progress or past on this project. The data access tab which show you all the data sets containing in the project, as well as direct links to Motu interface, OpenDAP, FTP, and WMS. By clicking on the small information button, you arrive directly on the articles of our Help Center by linking with the chosen access mode. And these articles are there to explain to you how these download modes work. So the Contacts tabs allows you to contact the Help Center. And then you have the documentation section with the links to the license, the user manual, and the quality information document. The user manual contains all the technical information relating to the project, and the quality information documents provides information on all the more scientific information or information relating to the mode of data acquisition. If you like the project, you can share it with the share icon here at the top right. This button allows you to copy the URL address of the project. And to visualize the variables of the project, you just have to click on Add to Map. And you can then choose the variables of interest present in different datasets of the project. So let's take the seawater velocity in dataset hourly here with the H in 2 dimensions. And I click to Add to Map. So we have our 3 variables open on our interface. You can easily pan around the map by holding down the left click and zooming in and out using your mouse wheel. For more visibility, you can change the priority order of the layer by dragging them up and down. And I choose to add layer or not by clicking on the eye. So we see that 4 to 5 icons are present. The first is used to download data. The second returns the product description page. The layer icon allows you to change the open variable by another present in the dataset. The gear is used to customize the layer, and finally, the log icon is used to apply a logarithmic scale to the data. This option is not present in all the variables. For the sake of visibility, I will modify the opacity of the current layer. I will change the color palette used with this, for example, or this. I can also modify the minimum and the maximum values to apply and decide whether or not to mask the values exceeding this limit. A unique feature of velocity layers is the style. And here I will make them appear as vectors. Okay, so in winter we don't really realize the temperature difference between the ocean and the sea. That's why, thanks to the bottom bar here, I decide to present data for 1 day in summer, like this. I will also change the color palette for the temperature layer to clearly see the difference. Okay, it's better. If I click on the map, I make a point appear, give me its coordinates here, as well as the values of the different open variable. And if I click, I can also choose to hide the layers by clicking on the little arrow here. If I click at another place in my map, I make a new point appear. And here we clearly see the difference of 6 degrees between the ocean and the sea in summer. I can remove my point with the cross here. So we can also clearly see the difference, the high current speed, in the Strait of Gibraltar. And zooming a little more on the bottom bar here, like this, I can even view the data hour by hour, like this. It's only possible because this data is hourly data. The left and right arrow on your keyboard allows you to change the date of the data visualization, but day by day. So we also have here a layer containing the chlorophyll A on the global scale. I will choose to view it like this. And we see that the resolution of this product is not good enough for our case here. So I will search for the same type of data, but for EB region. It would be interesting to see how certain elements are transported by currents, such as chlorophyll A. To open another variable layer, you can either replace an already open layer with another layer present in the same product using the layer icon here, which is not interesting here because we are looking for another geographical area. Or we can click on add layer and search for a product. So by default, so we have here our filter already open on our not data store. So I can remove our filter, or I can also modify them. So I will remove our filter here. So I want chlorophyll A, so I will choose the plankton variable for EB region. And I also want daily data on a numerical model. The first project offers is a forecast model here, and the second is a multi-year product. So I will choose the first, and I can directly access to the variable by clicking on Add to Map. And I will choose my variable in daily dataset. So it's much better. I can remove the other layer here, the global, and I will bring back to the fore the current velocity. So we can clearly see that the chlorophyll is well transported by currents, but also that the highest concentration of chlorophyll are at the mouth of river. You will notice that another option is available with the chlorophyll layer. You can select the depth level on the right. It's possible because it's a 3-dimension layer, unlike current velocity. By default, data displayed are surface data, but you can change these parameters by clicking on the scale. You can zoom in and out with your mouse wheel here. You can also use your up and down arrow on your keyboard. Okay. Above the scale, you have different objects that can be created. Point, as seen previously, lines for creation of transect, and area. lines here and area. Object creation is useful for visualizing a graph based on our open variables, but also for downloading this particular area. You also have access to the MyOcean viewer settings here, where you can, for example, change the units of the object in kilometer or miles. Graphics appears with the creation of object. This is a representation of a sample of the data. For this location, you can delete graph here or make other appear here. You can also decide to download this data in CSV format here, but you must enter your Siemens identifier. Access to data download is reserved for user with an account. As I remember, the registration is completely free. Your identifier will be requested if you have not filled it before, each time you wish to download data. So I can connect directly here or here within the settings or here in the download tabs. Okay. Not that the downloading of this data is only carried out on a sample of data. It doesn't reflect all the data of your object. And this, even if you increase the resolution of the graph like this. So let's move on the data download part. To do this, let's go to the download icon here of the variables you want to download. Here the chlorophyll. You can here we need to fill the geographical area. You can either define on map option, use the define on map. With this option, you can draw our area of interest directly on the map by maintaining left click, erase our selection using the cross, or even select a previously created object. In the date range section, you must fill in the time range, the time period you are interested in. Next to it indicates the time period available for this variable in the project. Be sure to indicate dates including this one. In the same way as the define on map option, you can automatically select the date of your visualization by clicking on as in map. Here for the, all right, and here as in map. So the same way for elevation range here, but I will stay on surface data. The also download part allows you to additionally download other variables present in the same dataset. And the final step is to upload your parameterized data. A word of caution though, downloading via Motu is subject to 1 GB data download limit. If your request exceeds this limit, like this, for example, like this, a red message appears. The links takes you to the data access tab. from where, by clicking on the information icon, you have access to articles from our Help Center, I said previously. Next to it, you have the Show API Request button, which allows you to obtain the requests that correspond to your parameterized data. This request is useful when you want to download your data programmatically, for example. In case of problem, you can contact the Help Center by clicking on the small bubble at the top, Talk to an expert. If you have a problem, in particular a download problem, it's important to communicate your API request to us so that we can help you as best as we can. To do this, I will open a chat session here and click on the request, copy, and paste it in my message. So we also notice that on the home tab of the chat, you have direct access to our article present in our Help Center. By search for a project, you can search a project by entering keywords like MyOcean. And you have, by the way, an article tells you how to view data on MyOcean Pro, like in this presentation here. The MyOcean viewer also has a sharing functionality by clicking on the icon here. You can then share the links of your visualization with whoever you want, create an object or even a video, or even generate an embedded link to include your visualization on your website, for example. So finally, we have the information icon here, which details all the keyboard shortcuts you can use on the MyOcean. And don't forget that we have some articles available on our Help Center concerning the MyOcean viewer, but not only. The user support team is nevertheless here to answer your question and helps you if you encounter difficulties. Thank you.
Thank you, Anaïs. That was a really nice presentation.
Thank you.
And we have a few questions already for you.
Okay.
If you could just stop sharing your screen, and we'll share.
Okay.
Thank you.
Up.
Go.
Uh,
I think you might be able to see it by now on the screen. So the first one is, I think it's just for me. Is this service totally free? Yes, it is. Like Anaïs said it already. Yes, it is free. You just have to register via Copernicus Marine Service, and you will have access to the data and to the viewer as well. Second one. Why do you choose the first chlorophyll A package and not the second multi-year?
In my presentation, I will focus on the NRT product, the near real time, but of course you can. I can choose multi here, but for this presentation, it was more was easier for me to show you the NRT product, but it doesn't matter.
Just a matter of choice then.
Yes.
Great. The second one. I didn't see a bathymetry product in your catalog. Do you have one?
Yes, we have bathymetric data sets in our catalog, but bathymetric files is only available with FPT access. So you can have a lot of information about FTP access in our Help Center. It's another way to access our different data sets and project.
Okay. And last one for now, I've tested on different products such as sea surface primary swell wave from direction, but I was not able to show it in a vector field. Is it always possible?
Not for the moment. We work on an improvement of the MyOcean viewer. We work on this field, apply vector on the wave variable.
So next one, amazing and super helpful information. Thank you. I wonder what is the size of the file that you can share. Also, will the recording session be available in the first part for you, I guess, Anaïs?
What
second one? I wonder what the size of the file that you can share. Oh, I think he means when you said you could share the files with with someone via email, you could share your viewer.
When you share your viewer, your visualization is not a size, but because it's only your visualization, so your interface. If you the size limit for the files is only when you download your data.
I see. So just share a link, basically.
Yes, share a link.
Okay. And for the second part of this question, yes, all the recordings will be online on our YouTube channel, but also on our Padlet. We will put the link in the chat. And the last one, I've tested on different, this one. Okay, we have just done it. Great, I think that's all. We have one more, which is coming. If you just bear with us a second. I think some of you must have put it on the, so last one. Is it possible to download wave data in only one point, like 0.1 lat and long, not in an area?
Yeah, it's possible with the object, point object. You can click just on your visualization, make a point, then you can download this data in this particular location. You can also fill manually your area if you know the latitude and longitude coordinates. So you can fill manually and then you can download this particular point.
Great. Thank you very much. And I think that's all for the moment. Thank you very much, Anaïs.
Thank you.
And now we will pass to our next speaker of today's session. That's going to be Daria Andrievskaia. She will show us. She will show us a tutorial about on how to use our marine products on QGIS. Daria, if you're with us already, yes, perfect.
Yes, I'm here. You hear me?
Yes, loud and clear.
Great.
Whenever
So
you want.
I share the screen, right?
Yes, whenever you want.
So hello, everyone. My name is Daria. As has been said, I work at Noveltis, and today I'm here with you for about an hour to show you how to use Coperncius marine service products in QGIS software. So our plan is that we're gonna first start with beginner's tutorial. So it's going to be more detailed step-by-step instructions about how to use products that we can download from the platform, how to ingest them in QGIS, how to work with them, and see what we can do with them. And for the second part is going to be a brief sneak peek of an advanced scenario. So it's going to be a short introduction of more complex exercise. And I'm not gonna do the step-by-step instructions. I'm gonna just show you the results of already existing project in QGIS. And yeah, just tell you some specific features we used. And if you want to have more precise instructions on this advanced scenario, you can go to Padlet. There's gonna be a video about this scenario with full instructions, and also I believe there's going to be a PDF version. So let's start. And first we are going for beginners scenario. So in this scenario, we're going to study extreme wave conditions, which occurred in this region, in the Ibero-Biscay Ireland region, during the winter 2013-2014. So these extreme wave conditions were characterized, of course, with significant wave height, which is a variable which is used in oceanography as a variable to measure the heights of waves. So also, yes, what we're going to do is not only study the evolution of this variable, but also how we can use it. For example, here we decided to apply to show you this application as how to build a safe ship route, trying to avoid extreme waves. So what we're going to use in this exact tutorial, we're going to use two model products from Copernicus Marine Service. First is this one, is ocean wave reanalysis, which we will use only significant wave height. And the second one is ocean physics reanalysis, which we're going to have our current velocity and direction from it. So I think Alexandre already explained to you how to download data from a website. You log in, and I think yeah, he mentioned. So here we just go very briefly. You subset your data. You choose whatever variables you want, the place, and of course the date. So I already prepared it, of course. I don't need to do it again. And our products both are in hourly. Yes, hourly. Okay, hourly, daily, monthly. But what we're gonna use it daily mean. So we go into our QGIS software. So you open, you create new project. Here you have just new. And first, what we're going to do is we're going to, of course, add some background to have something. So we go to layer, we add layer, oh, sorry, create layer, and add. And yes, this one, WMS. And here, I already have map server demo, but if it's a first time you work in QGIS, you might not have it. So you click on new, you put a name, whatever you want, and you put in URL. I don't have it right now, but you will have it in a PDF version. Then you add it, you click OK. And here we have it. So we connect. And we have several of layers which are included. We are most interested in Blue Marble World. We add it and we close. So here we have our background. We zoom in our more or less in the area we're interested in. And just a quick, yep. So what we're going to do next is we're going to map our variables from Copernicus Marine Service products. And for this, we use this plugin, that's CDF to GIS plugin. And this plugin has been developed by Noveltis engineers. And this plugin is made just to ease the process of ingesting Copernicus Marine Service products into QGIS, because basically all the products are in a CDF file format, which is very good for handling big data with a lot of variables, like nested variables. And initially in QGIS, there's not very convenient tool to use for importing CDF files. So this tool is much more convenient. And if you want to read more about it, and of course, if you want to have this plugin, which you actually should have to follow this tutorial, you can go to this page on the Copernicus Marine Service site, which has all the information about it, how to download, how to install it in your QGIS, and also even some tutorials. So I already have it. And here you can add your netcd files by browsing through your directories, or you can open your directory. For example, I have these two products I'm interested in. All the products been downloaded and they've been a bit adjusted. For example, here I think it was just cropped to the dates we need. For example, we're going to look only on winter of 2013-2014, so from 1st of December till 28th of February. So I'm going to just drag and drop them here. Where is it? Oh, yes. So here you can see all the information about what this product contains. For example, the variable, the full name, what's the dimensions and units, and here's some metadata options about. There are a lot of things. If you want to know more about the plugin, you go and go check the website. So first, what we're gonna do, we're gonna work with our. Wait a second. We're going to work with our significant wave height. So first, we're gonna map it, and we go to our product. We click and we add layers. So here you can see that we have layers. Basically, we have data frames, time frames for each day during winter. One time frame per day. So that's a bit too much. So what we're gonna do, we're gonna choose each 10 days. That will take some time. So you basically hold Control and you choose one by one. Take 20, 30, oh, okay, 31, whatever. 10 and 28. So we chose some. You can change the name. I'm not gonna do it. I put add and close. So now I can go back to my project. So here you can see already the evolution of significant wave height. So what we're gonna do is we're gonna change its properties a bit. Hope you don't see it. Oh, it's here. So what we're going to do is here it's okay. We'll put more neat numbers. It's 3, so we put 4, for example, and we invert it like this. And also what we should do is right now it's continuous, so we'll do equal interval and set only 5 classes like this. And also we don't need this big precision, we can put 1. So you do this, you click apply, okay, and now we see our evolution of a wave here. So of course more red red color represents more extreme waves than blue. So what we do next, we right click, we do styles, copy style, and we choose all our time frames by holding shift and choosing 2 limit ones, and we paste our style. So now they all have the same style, and here you already can see how our significant wave changes. So here, yeah, you see that it's very, very red, but it's actually, again, a small note. Here we chose that the max value was 4, because it was stated that max value for this exact layer was 3, for example, but it's not the same for this, for example, layer. Let's choose the one that's super red. Okay, for example, this one. If we go to properties, we see it's 4, yeah, because we stated it. But if we go to information and scroll down, we see that maximum value is actually 8 here. So each raster layer, these layers are rasters, they have their own min and max, of course. And because we copied style, we assumed that the max is going to be 4 for all of them. So what we can do very briefly is to actually change, so not to have this two red picture. We go back to symbology and we put, for example, we saw that it was 8, right? So let's assume it's 8 is a max. We apply. Okay, and we copy our styles again. Oh, nope. Paste style. So yeah, like this, you can see that, for example, the first day is less active right now regarding waves. And yeah, you can see now how it changes. So yeah, it's up to you. You, of course, can put whatever margins you want. It depends on what you want to represent. So this is done. And next, what we want to do is to choose only one specific time frame. So to ease our future work, of course, you can do for several, like you can choose several of them. We're going to choose, for example, this one, 28th of February, because, well, we see that our significant wave height is quite high, maybe actually too high. Let's see. Okay, well, could be this, whatever. So next feature we're going to show is going to be a little like sub exercise. In our sub exercise, as I said before, it's already open. We also imported another product, which is current. So here we will try to work with it a bit before moving to our safe ship route. So here we have our current. You can see that there's northward seawater velocity and eastward seawater velocity. So we basically have two components of the same vector. So what we want to do is we want to map these currents into our project. And that's why I said we use only we choose only one time frame, so not to import too many things, so not to lose some time. So we decided, for example, yeah, let's choose 10th of February 2014. So I do the same. I choose my variable, I click add layers, and I choose 10th of February. Where is it? 10th of February, exactly. There's also depth, but it's only one. You can maybe notice that there was no depth on significant wave height because there's no depth there. So we import only this one. We add and close, and we do the same with our next component, 10th of July, July, February. Okay, add and close. Great. All the layers you added, they're also here, you can see. And this is important because we're going to use it. First, we go back to our project and you can maybe observe something. It's not very, actually, it's not clear at all what's happening right now there. So we don't really need it. We're going to untag them, so not to get lost. And we go back to our plugin. So here, we go to the layers tab. And now what we're going to do is we're going to see the current direction and velocity by basically combining two vector components we have. So for this, you go to layers, you have your both components, you choose them both by holding Control, right click, and here you have vectorize function. You click on it and we have a new window. So you choose U and V components, and well, layer U is U, layer V is VS. As we look at the current, we choose current, and downsampling, we choose X5, for example. Downsampling basically means, so now what we're going to do, we're going to see basically arrows that will show us the direction of our flow in the sea. And X5 means that downsampling means that we reduce the amount of arrows like proportional to this number. So for example, if it's X5, it means that 5 less, like your screen will be 5 times less busy. You of course can adjust it. It's just for clear visualization. Output directory. Let me just choose some. And we click on close, vectorize. Yes, we can of course change the name, but yeah, we close, and now you can see these arrows. Basically, they are showing our current. So as we can see here, there is not really specific pattern in how it works, in where it goes, more or less we see, but not much. We see it goes around the bay, for example. So what we're going to do is we're going to adjust a bit our scale. Right click, properties. You go to symbology, and here down you have style, and you can load the style. And for this, you need to go to the directory in which you have this specific style, which is called current scale. I guess it will be provided to you. So yeah, we needed to load it just to adjust our scale, because before it was quite strange, and now it's more neat. We apply, click on OK, and now we see that our color basically changed. It means that here you can see that each arrow with each color, it corresponds to some specific velocity. And as you can see, their velocities are not like huge, let's assume. So like this, you know how to map some vector fields, which could be current, which could be wind, also wave directions could be mapped like this. And now we can move to our next exercise. So we're going to do a ship route, safe ship route. So we assume that we need to go from one port to another port, but somehow we decided to go exactly when it's going to be a storm. Why not? So let's try to build a safe route which will help us avoid this area. So for this, first, what we're going to do, we're going to add some specific layer, additional layer, each external. For this, we go to layer, add layer, and we go add vector layer because it's a vector layer. And we're going to browse to the data. So here we have this specific folder with a shapefile of world ports. So ports which are of like mostly major ports of the world. And this information you can also access through the link which is given in a PDF version of tutorial. So here we need only shapefile itself. So the shapefile format. We open, we add, and we close. Here you can see that we now have lots of green dots all over the coasts of the world. So this is a ports, but they're not really representative. So we go again, right click, properties, symbology. And here we can also load the style. And again, in this folder, with the shapefile, there's also a specific style to facilitate work with this exact layer. So here you can see that all the dots are separated by 4 classes. So large, medium, small, and V means very small. So we apply. Okay, what we see now, we see that ports are different points now, different marks, and also have their names. And the names are a bit ugly, to be honest. So I'm going to change it a bit. So if you want to play also with how the style of a layer, here, for example, we have labels. We go to labels, and we can change them. I think it is background, and probably opacity. If I put opacity like this, oh yeah, great. So no ugly ellipses. And also I'll change color of the text because I think it's not really clear what's happening on the ground when it's on the ground. Okay, why not? Okay, so now we have a lot of ports. but we actually don't need them because we need only in this area. So what we can do now is also apply such a function as filtering. So we have our big layer. WP actually means World Port Index, if someone doesn't know. And what we're going to do is right click on this layer and there's filter. So filter is actually very useful feature you have, because like this you can filter by many conditions and really like subset your data to smaller part, which can be useful. So what we're going to do here, we're going to subset it so we only have our ports in this region. So you might choose different different conditions and so on, but we already did this condition. I copy pasted here. So what we want is, as in each port actually has information in country. I don't see, where is it? Okay, where is country? Somewhere. I cannot see it. Okay, country here. Yeah. So what we want to choose, because we're gonna, for example, use only this area, so the Bay of Biscay. For example, here we're gonna choose only Spain and France, because that's the regions that are adjoined to these waters. And then also, for example, what I chose, I filtered by longitude, latitude, so to show only relevant ports. So I can put test. So it returned only 42 rows, so it means that all others are out. And I click OK. And now you can see that only these ports on this region are shown and all other just disappeared. But of course, if you click on filter again, here is a little icon, and you remove this condition and click OK again, all the ports that you had, all the previous layer will be returned to you intact. So it's not like it's lost. So okay, now we have it. And what we're going to do is we're going to draw a ship route between two ports. Let's choose this one, Ferrol, in, I assume it's Spain, maybe it's Portugal actually. No, it's Spain, yeah. So in here, oh, it's very slow. I will, no, okay, I'll leave it. And let's, yeah, choose this one port. And well, let's start. So what we do, we want to create our new layer, which is going to be points layer. So we go to layer, create layer, new shapefile layer. All the vector layers are basically shapefiles. So we choose in geometry type. It's very important. We choose points because we're going to put points. And then file name, we go, I'll choose ship route. Right. Oops. Okay, yes. So we save it. Now we have our new layer showed here, but there's no points because we didn't add anything. So we click on it. We click on this editing mode. And now we choose this exact icon, which will allow us to put some points. Now here you see some cursor, which you can put on, choose a point. So first we will put, of course, our port. And here you need to put ID. So just put them one by one. So what we're going to do now, we're going to add some points, trying to follow as close as possible to the shore, because we see that there's less of the wave height is less there, and also can see that the current is, well, here it's quite fast, but here is not. But also, if you want to really make it more advanced, more hard, you can try to also follow the current itself with all the arrows. So what I'm going to do is I'm going to put another point, for example, here, and like this. Yes, it's going to be a bit it'll take some time. I'm not going to be very precise for this because it doesn't make much sense. It will take too much time. So it's 3. Let's assume 4. Somewhere here 5, 6. Where is our port? Okay, this is our port. For example, 7, and let's put our port as 8. Okay, great. So we added some points. They are a bit lost on. I will change the style. And before we move, we should untoggle this one icon so we save our changes. Great. Let me change the style quickly, maybe to some blue. Is it better? Well, a bit, yeah. But actually, let's change it symbology to something very popping like this. Apply. Okay, well, yes, great. Now we really can see it. So now we have our points we chose. Again, it can be completely different from yours. So what we want to do now is we want to add longitude and latitude, so coordinates to these points, because after we want to create a ship route, so basically the path, we need this information to be written. So what we're going to do, we go to processing toolbox. If you don't have processing toolbox, at some point you go here, processing here on a layer tab with processing, you click on toolbox and it appears. So we're gonna search for add geometry, and here we have it, and it's usually in vector geometry. So we click on it. Okay, it's here. So ship route, yes. Layer CRS, yes, we want the coordinates, longitude, latitude, and we can create a layer, but I want to do that. Just run. Okay, we see new layer. That's basically the same, you can see now. But if we right click, open at, oh no, I misclicked, sorry. Open attribute table. Now we see that each point has X coordinate and Y coordinate. Great, that's what we needed. Also, what you can do, you can also see what's the significant wave height at these points. For example, if you want to check, but yes, I put them properly. There's no danger, no extreme wave conditions there. To do so, as we have only one raster layer, which we want to extract data from, we go to sample, I believe. Yes, sample raster values in a raster analysis tab. Double click, and you can put added geometry info or your ship route, doesn't really matter. And a raster layer, you choose one that's what we have here, what you want to extract the data from. So that was our 10 of February. 10 of February is this one, I believe. Yep. So again, you can save. I'm not going to save it. Run, close, and here again, same points, nothing changed except for attribute table. Here you can see the values of significant wave height. According to each point, you can right click flash feature to see. Okay, you see that here it flashed. Let me do it again. Now it's here, so you can locate them. And you can see that, for example, our first point and our third point, no, not third, yeah, only first point doesn't have any data on it, because I guess it fell on, yeah, it fell on ground, you see. So there's no raster layer at this point. There's no data, but so here you can see that, for example, on point 8, we are very good with our significant wave height. For example, you know, well, more or less it's not too big, but still, if you be more precise, it's you can adjust it so it's less dangerous route, let's say. So we close it, and what we're going to do now is we're going to have our path finally. So for this, we are going to search for points to path. Points to path, yeah. So I'll put it more precise. So it's points to path here in vector creation. You double click and then you choose one of a layer. So you can see that you can choose only points because, well, it's points to path. What is important here is you should put the layer with geometry info. So with our latitude and longitude, otherwise it's not going to work properly. So we put this. Here we don't really need much. It's some optional stuff. Again, you can save. We can run. Hope it worked. Yes, great. So now we can see a path between these points. So it's being connected. And let's change its style to make it more popping. Okay, let's do, I don't know, make it thicker and okay, I'll put even more. Let's put, I don't know, 1.6, maybe it's too much. Okay, no, it's good. So now we have our path. And what we want to do is, well, we calculated our ship route. And what we want to do is to know the length of a route and maybe, yeah, like more, you can actually have more data, but we will stop only with a length. So first, what you can do is you can have length of the whole route, right? Or also you can have a length between each of the points. We will do both. And for the first, to know the length of a full route is quite easy. We use the function we already used, add geometry attributes. But now we use it for our path. And important here, we use not layer series, but ellipsoidal to have it not in to have it on in real coordinates. So we run, we close, and we have a new line you can see on top. And if we right click and go to open attribute table, you can see some information, and also you can see length of a full route. It's in meters, so you can see it's 1 million and 100,000 whatever. So next. Okay, that was easy, great. But now I want to see each part of our route. What's the length of each part? So for this, it's a bit longer. And for this, we go to first, we have our line, right? And that's the one line. So our the QGIS thinks that is one line and a lot of points. So what we want to do, we want to split lines at points. Yes, as I already used it, it's here, but it's supposed to be in the saga part. It's split lines at points. We ignore that. So here, what we use is we choose our path because, well, we don't care if it has length. Like, so for example, we don't need our added geometry info layer. So split features are the features we want to use to split our path. And for this, we're going to use ship route. Yes, and separate lines. Yes, good. Run. Okay, it will take some time. Okay, I think it's good now. Yep. Now we have our new line. Again, it's the same line. Nothing specific happens. Open attribute table. We can see only the each part of it. But as we split, before we move next, for basically next step is to calculate our lengths. So to do this, we first need to fix geometries, because very often when you use some conversions, for example, from raster layer to vector layer, or the opposite, when you use some splitting, some more advanced tools in QGIS, for example, this saga is more like advanced, and grass also. Your new geometry has some errors, so you won't see it with your own eyes, but when you will proceed with some spatial analysis, it won't just let you proceed, but it will say, I cannot do anything, please fix your geometries first. So what we're going to do is we're going to fix geometries by just put fix. Okay, it's here in vector geometry. Double click, we have intersection. Again, you can save it, run, close, fix geometries. the same line. Again, as I said, you won't even see what happened, what changed. And the last step is to know the length of each part. And for this, we do the same what we already did. We just go to recently used and we see add geometry attribute. So we already did it, so we do it again. We fix geometries, we put ellipsoidal, run, close. New layer, open it. And now you see your values, distances. Actually, I missed something. Let me really click remove this layer, because when I was adding geometry attributes, I think I forgot to put, no, sorry, it was actually good. Fixed geometries, yeah, it was good. I was just thinking about another tool which actually needs to have more input. Okay, so it's like this. You see the length in meters again between each of them, and you can flash the feature to see. For example, okay, here you can see that the length is somehow 0, which is strange. But if you flash the feature, this feature actually doesn't exist. At least we don't see it. Well, cool. What can I say? Yeah, you see that also a bit, how to say, not in order. So actually, I did notice this happening sometimes. Yeah, if you flash all of them, you see that they all are included. I did notice that sometimes when I do this procedure, it creates a new feature which has like 0 everything, basically 0 length and so on, and it's not even like on the map. I honestly don't know why. Well, it doesn't really, it doesn't really change things for us. We can still see it. We can still see our distances. I'm gonna look closer on that later, but yeah. So that's all for this exercise and for the tutorial, for the beginners one. And so yeah, here we learned how to map products, Copernicus Marine Service products in QGIS by using specific net plugin, which is called net CDF to GIS. And yes, we learned how to visualize our evolution, how to do vector fills, which is quite important at some applications. And using this information, we also now know how to work a bit with geometries, add layers, add point layers, turn them to paths, and also to find some metrics like length, for example. So that was all for this. And I guess it's questions now.
Thank you very much, Daria. It was a really interesting presentation, and indeed we have a few questions.
Okay, I stop.
Yes,
right.
please.
Okay.
Thank you.
Okay. So the first question, great explanation, I agree. Do you recommend any QGIS course, please? Or do you teach one? It would be amazing to gain more skills in QGIS.
Okay, well, me myself, not really like specific course. Well, first of all, if you go to Copernicus Marine Service YouTube channel, they have videos, recordings of the same basically workshops that's been held before, like last year and before. And there are several videos. I think I remember at least 2 or 3 different topics with 2 or 3 different regions. So there are more information about, like, more examples on how to use QGIS. But also, if you want to do something in QGIS, you basically go to Google, whatever you use, and put like, oh, I want to do this and this in QGIS, and there's going to be plenty of information, plenty of people who did it. So, and also a lot of YouTube videos. So I cannot recommend some specific, but just searching, putting a request on the internet is usually has a lot of answers.
Okay, thank you. Can we merge multiple rasters on QGIS? I want to merge multiple parameters variables in one raster and have the time as the 3D axis of the matrix.
Multiple rasters. Okay, well, I think what I know. No, we usually mean if you mean that each raster corresponds to each variable, then as I saw, usually variables are imported one by one. So yeah, but I want to well, that's for example for this plugin which I showed. That's a good thing to use because it allows you to easily work with this values of raster and the time axis. Because if I remember correctly, before when we didn't use this plugin, it was a bit more how to say, not really clear because it shows you only like 2 dimensions, like omitting the third one, for example, if you have depth or something. So if you did not use the plugin yet, you might try to see what's there. Like maybe you actually see that it's more convenient for you, for your purpose, what you want to do. But otherwise, if you already used, then I think I cannot really answer this question.
Okay, thank you. I cannot work with the plugin. I get this error attribute error non-type object has no attribute, right?
Okay, so this is probably one of the many errors that happens when you try to use the plugin in a QGIS, because it all depends on the version of your QGIS. With some versions, NetCDF plugin works perfectly and fast and nice, but with some, it's gonna take you a lot of time to configure it. So the last information I had that the most stable version of QGIS with NetCDF was 3.18, I believe. Me myself, I use think 3.20. Yeah, and it was a pain to work with plugin to like manage it. Also, I know that 3.10 is also easy to install. So most likely, if you have this attribute error, so basically the errors you have from like Python code, that all depends on the version of your QGIS.
On that, I just wanted to add that I got an information from the Help Center, and there will be an article on this topic soon, because I think we had the same question in the last workshop.
Yeah, or some other attribute error, but yeah, like close to that.
Okay, so yeah, soon you will know more information on this.
Okay.
And yeah.
Thank you. Can I export shapefile table data to TXT?
Yes, you can. In when you have your vector layer, you right click, and there's going to be, I think, exactly export data or something, and you can choose how to do it. I actually can look if yeah, you right click, there's export and save features as.
Would you like to share your screen, Daria?
Yeah, maybe if I can.
Sure, go ahead.
So if you see it.
Yes.
Okay, so for example, I have some layer with points, which is shapefile because all vector layers are shapefile, usually. You right click and there's export and save features as, and here you can choose any of formats basically. There is a TXT table, I'm not sure, package. There's a comma separate value, which is basically what you want, and you can later work with that. And yeah, here you can like tune it. You can put geometry like XY, for example, if you know for sure that your X coordinate is X and Y coordinate is Y, it's going to also import additional geometry. And so yeah, you can do that, and you can even like subset your features. For example, if you have a huge amount of features but you don't want to export them all, you can first go to here, choose your here, if you see this, you select feature by polygon. If you select feature, you select basically one by one, and then you right click and there's selected, save selected features as. So for example, now it's not available because you don't use it. I mean, you don't have it. But as soon as you select some features, you can export only specific features in like different formats and in CSV as well.
Thank you. And I think we have a few more questions.
Can we use this tutorial with ArcMap? I don't think so.
I mean, it's quite specific to QGIS. So
maybe it's something to consider for the next workshops. But I guess the advantage of QGIS is that it's open source, right? It is free, and
yeah,
that's why we use it as well. But yeah, and one last one.
The null value on the attribute table, could it be due to a previous fixed geometry?
Well, it could possibly. It should not, because that's why it's fixed geometry. It should not have any errors. But the point is, if you do not fix geometry, you can have some how to say, like extra things. For example, if you want to try, you can try not to fix geometry, or also, for example, not when you have your points layer, do not add latitude and longitude to it, and try to create a path from it, from without coordinates, and see what's going to happen. Most likely it's going to happen that it will create a circle, not a path. So it will like circle it, and then you will try to find, you wouldn't able to split it, if I remember correct. So yeah, it could be fixed geometry. I will try to look at it closer, but yeah.
Yeah, I think that's all for the questions at the moment.
I think so as well. Can move on to the second exercise, maybe, Daria, if you're ready.
Of course. Just a second. Okay, so I hope you see my screen again.
Oh, good. Yeah.
So for this part is going to be a more like advanced scenario. So basically, we're going to study, of course, the same area, but we're going to study a marine heat wave, which is extended period of regional ocean warming. And well, we're going to study one specific period of time. It's the summer of 2022, because as many of you may know, during this summer 2022, Europe has been hit by an extreme heat wave. So the air temperature was like utmost, and of course, such event will bring some impact on the marine environment, of course, on the ocean. So here I wanted to see how this heat wave brought a marine heat wave, and yeah, see how it evaluates and so on. So here you can see some additional information if you want on the slide, but we're going to our project. And for this, as I said, I'm not gonna do like step by step everything in details. I already have my project loaded, as you see, with all the things done. I'm just gonna show you some results. And first, I will tell you what products we used. I don't see, because of the Zoom, some of the slides, some of the tabs. So for this, we used the temperature, seawater temperature, of course, and also we used wait, what was yes, oxygen, right? Dissolved oxygen in seawater. So for oxygen, I will explain a bit later why we somehow interested in oxygen. We used biogeochemical analysis and forecast. here. All the links again are available in PDF. And for the seawater temperature, we used global ocean physics analysis and forecast because it just had more more recent dates. But when we were downloading it, we of course did not subset the whole world. We don't need it, so we just choose the EB region. So that's it. And so let's look. So we having 2 exercises. First, we're gonna work mostly with seawater temperature, and the second is with the oxygen, dissolved oxygen. So in the first exercise, what's been done first is, of course, our temperature was mapped. Here you can see the evolution, and oh, just a second. Oh, yeah, you can see how the ocean gets warmer and warmer with time. We can basically see, for example, well, the sea, Mediterranean Sea, well, it's enclosed sea. It's of course going to be more warm, but here we're more interested in this part because that's our region. And you can see from end of June how it starts to spread, like this heat wave, marine heat wave is getting quite red. So of course, after we ingested the data, we adjusted the style a bit so it's more representative. So again, here we just choose only one time frame to use it further, and it was July 20, I think, this one. Yeah. So, yep. What's been done next is, as you can see here, we have a lot of areas which are not exactly EB, for example. Well, Mediterranean Sea, we're not really interested. North Sea, we also, for example, not really interested. So what we want to do is to narrow down our analysis, and also it will be it's a good example to show you how to what you can actually like basically crop your raster layer. For this, we created a new polygon, and the new polygon created the same way as we did with points in a beginner's tutorial. The only thing is you choose another type of vector layer, it's not point, it's polygon. And then we clipped our this layer. So our raster layer for 20th of July, we clipped it according to this zone, and we got this, you see. So to clip it, you go to raster, extraction, clip raster by mask layer. Here you choose your layer, you choose the mask layer, so the basically polygon vector layer, and you have this. So next, what we want to see is we wanted to see the we want to see evolution of our variable of seawater temperature in some specific points in this region. The point is that, of course, you can do what we did before with beginners tutorial by basically creating a new point layer and choosing any putting points and locations you're interested in. But if you don't have any like particular interest, you can also do the random points, which we wanted to show how to use. And for this, you need to have this region in polygons, like in the one big polygon. And you can say, well, we already have it. Yeah, cool. But the point is that this polygon also intersects with a land. You can clearly see it in here. And we don't want this because if you're going to use some specific one function, which I'll show you, it will randomly put points in this polygon. So if you choose this polygon, we're going to have some point on a land which we are not interested in. So what we do is we vectorize our clipped raster layer like this. And again, you can see it again goes to the ground. And to do this, it's raster conversion vector. Yes, polygonize, sorry, here. And after it's been vectorized, what we did, of course, we fixed geometries, as I told you before, and you can see that when you fix geometries, it actually excludes the ground parts. Also, for questions about fixed geometries, if you want to see more, you can check. I think it's valid. I check validity, yes. So check validity is a function in vector geometry tab. You put your polygon, for example, area vectorized. Where is it? here, area vectorized, and you run, close, and you have, let me, oh my God, it's too many things activated. Yeah, here, for example, it's very quick, but yeah, you can see that this dark, what is this, red, whatever color is valid output, and all the orange is invalid output. So if I remove it, like invalid output, we can see that only these polygons, which are highlighted now in red, are actually valid. So it means that all others are not. So like this, if we won't fix our geometries, we will lose a huge amount of data, a huge amount of stuff for future. But also, as I said before, you would be even able to run some functions, some features, because it will just tell you like, I cannot work with that because it's broken. So just a little introduction to this. I'm gonna remove it. So we fixed it, right? So now we can see it's great, it doesn't touch land, basically, it's not intersects land. So, but here we can see that it's all lot of different polygons, like for example, this is a small polygon, this is a small polygon, and so on. And as we want to put our points in a polygon, we want it to be 1, because if we're gonna use this function, which I'll tell you a bit later, it will put points in each polygon. So we're gonna have a complete mess because we have like some polygons are like this, you see. And if we choose, oh, I want 10 points in my polygon, it's gonna put 10 points here. So no, we don't want that. So for this, we do this. We basically dissolve all our polygons in one. And for this, you can just put dissolve, yeah, this function. You just put input layer, you run, close, great. So now what we were doing is putting points, random points. In the vector creation, you have random points inside polygons, I believe. Yep, I think so. Yeah, inside polygons. Yeah. So you put your input layer. You put points count or point density, basically how it depends on the criteria you want to have your points. And you choose the amount. For example, if I chose points count and I choose 15, it means that it will put 15 random points in a polygon. That's all. And like this, that's what I got. You can see there's a points, I think there are 15, maybe 10, I don't remember. And you see they're randomly scattered in a polygon, not on the ground, not on the land, we see it. And of course, it's going to be different for you because it's random points, so I scattered randomly. Next, what's an interesting thing to have, and which basically was the target, we want to know the values of like the temperatures on these points exactly. And previously, like last tutorial for beginners, I showed you how we did it with sample raster values, I believe. And it was, you could choose only one raster layer for this point. So if you know exactly which raster layer you're interested in, that's a good stuff. But if, for example, here we have several days, like what we have a whole summer, each 10 days, and we want to have the temperatures of the water during every, like from each raster layer, so for each day, for each point. And for this, we go to, I think it's add raster values. Yes, add raster values to points. It's again in Saga, so you can see it's a bit more like advanced and so on. It's even like blurred, at least for my version of QGIS. So we go here, we put our points, and it was random points, I think. Yep. For example, here, I think it's recommended to choose this one, refer the B-spline interpolation. You can read more about different functions. And the most important is grids, because when you click here, you can choose any raster layer you have. Like here, you have all raster layers you have in your project, and you choose the ones you're interested in. So for example, I'm not going to run it, but I chose all of the temperatures because that's what we're interested in. And like this, we got this. Exactly the same points, nothing changed on the outside, but inside, In attribute table, now you have basically for each point, it has its own number, of course. It has a date, a time frame, and it has a value of a seawater temperature. And yes, they are, of course, ordered by like alphabetic order, not in a order that we assume it for date, you know. But again, you can flash feature to see which one. Okay, so which one, you know what, on 1st of June, it was 13 degrees. Great. And next, a little, how to say, sub exercise we wanted to show is that's not really connected to the temperatures, like to the heat wave, but we decided why not? Because it's advanced scenario, right? So how to calculate distances between the points, as we already worked with points layers. So here, for example, you have a function, you have a layer, sorry, with the distances between each 2 points in the same layer. For example, if I flash them, you see between this and this, it's this amount in meters. Here, a flash feature, here and here, you see? And to do this, you have, I think it's distance matrix, distance matrix. And yeah, here you can choose between which layers, and yeah. But more interesting was also to find the distance between these points, which we chose, to some specific, to like nearest point from our layer. And for this, we reused this ports layer with world ports, as you can see, as we can already explain. And so what we want to see is, we want to see the distance between the point, each point of this layer, to the closest port of another layer. So basically find the distance between 2 point layers, but like the closest one. And for this, there exists nearest hub. I don't remember the full name. Okay, distance to nearest hub. Here, you put your both layers between which you want to find distances. And here you put measurement unit. Yes, that's what I was actually trying to do last tutorial, but it didn't work. So yeah, I mean, it wasn't the right tool. So here you can choose which measurement unit you want, for example, kilometers, meters, whatever. And it gives you this as a result. So here you can see the line between the points we chose to the closest port. There is also another function which called basically the same, but just with, instead of line, just points. It has exactly the same result. It just doesn't print you the lines if you don't want them. If you want to check, you can check, and maybe you will find actually that I'm wrong, and there is actually a difference between them more than lines. So that was the first exercise. And for the second exercise is just basically a small, how to say, like exercise to repeat what you already maybe learned in beginners tutorials, or if you didn't do beginner tutorial, you can see it here. So we mapped our oxygen, dissolved oxygen. And why was dissolved oxygen? Because the high water temperatures, high seawater temperature, it leads to deoxygenation, which means that the oxygen level drops. And that's, of course, not very good. I mean, too high oxygen level is also not very good, but very low is not good for species either. So that's why this value was chosen to show what else you can do in QGIS with these products. So they've been mapped, they've been, of course, tuned. And here you can see that the blue means less oxygen and red means more oxygen. And for example, let us see all of them really quick. So you can see that after 30 of June, also at the end of June, you can see that this area becomes more and more blue, so less and less oxygen. And this is actually quite coherent with what we got, because we saw for water temperature that water temperature was increasing from the end of June. So it's also a nice thing to like see the correlation. And here what we just wanted to do is to basically how to, again, subset some region. We chose one time frame. It was 30 of August. We vectorized it. I already showed you how to do this. Great, right? We fixed the geometries. And yeah, here you can see that fixed geometries are not really corresponding to the full layer. Yes, because I already applied filter. You can see it here. If you click on filter, I put basically, but I want the oxygen concentration be below, for example, 230, and it's in millimole per cubic meter. But again, just because I was like, okay, I want this number, you can put whatever, like, I don't know, let's put 300 and put test. Oh, apparently, basically almost every part, and you can see how many rows. What if I put 150? Maybe it's not even enough. Only 16 rows, you see. I don't even see where is it, but yeah, you can zoom. Okay, so you see, or you can put equal, you put some more conditions, but again, I already showed you the filter option, and it's just to like remind and to make it stuck in your head. So that's all, very, very briefly. And yes, here we just mostly, yeah, we learned how to map again our products, how to filter them, how to vectorize and fix geometries. Apparently it's important. And yeah, and the first exercise was mostly about how to crop area of interest, how to add some random points, how to extract data, and also to manipulate a bit with points layers like distance between them and so on. So that was quite a brief sneak peek. So yeah.
Thank you, Daria. That was a very nice explanation. Just to remind everyone, the tutorial that Daria just presented very briefly is already on the Padlet. So if you're a more advanced level, you can practice on your own. And I think we only have one question for you now. Do you know of any limitations in using Mac for this operation?
Well, me personally, no, I do not use Mac and actually never used. So I don't know. I cannot say. I think you just go to, I mean, mostly all these operations, I mean, they all quite standard operations for QGIS. You just go to QGIS website and read some, there's probably going to be some, how to say, yeah, like some tab saying some information about your operation system. And yeah, but that's all.
Great, thank you. And I think this is all for questions. Thank you very much, Daria. And thank you everyone who did some sort of demonstration. Alexandre, Anaïs, I think you're no longer here. But thank you very much for your contribution. It was really interesting. Yes. Cédric, if you also want to open your camera, feel free. So this is all from us, from this workshop. Thank you everyone for participating. It was really nice to have your questions and to have you here. So we have shared already the links to the Padlet. You can check all the resources over there. You will soon put the replays of today's and yesterday's session on YouTube, and you will be able to practice on your own and follow these today's sessions. We will have a third session on the 22nd of March to debrief on your practice, if you will have time to practice. And we'll also have our experts from yesterday's session with us. You can ask your questions, and it'll be nice to have you there. Thank you, Ergane, for co-hosting this session.
Thank you very much, Andrea. Thank you to all the participants and all the lecturers. And
Yes.
yeah, see you at the debriefing session.
Yes. Bye.
Bye.
Bye-bye. Thank you.